Welcome to the Wandering Mind, a quiet space for curious thinkers. Let me know what time it is and where you're listening from in the comments below. Then let your thoughts drift and allow the world to fall away. As we settle into a comfortable position, perhaps beneath the gentle weight of a cozy blanket or simply reclined in a favorite chair, let us embark together on a journey far beyond the confines of our everyday lives. We will traverse the expansive tapestry of the universe, a place where the familiar gives way to extraordinary and often weird outcomes. Our journey tonight is an invitation to embrace curiosity and marvel at the universe's peculiarities. We are not hurried, nor are we seeking answers with urgency. Instead, we allow ourselves to be gently guided by the cosmos itself, letting each discovery unfold in its own time, like the turning of a page in an ancient, cosmic book. And so, with a gentle nod to the infinite wonders that await us, we begin our exploration. We invite you to let go of the day's concerns, to breathe deeply and allow the soothing cadence of this cosmic journey to lull you into a state of relaxation. Together, we will wander among the stars, exploring the most peculiar planets known to humankind. Each world we visit will be a stepping stone across the universe, inviting us to imagine the unimaginable and to dream of what lies beyond. In the vast tapestry of our universe, where light often serves as a beacon of discovery, there exists a planet that stands as an enigma to astronomers and dreamers alike. It is a place where darkness prevails in a manner that defies our usual understanding of celestial bodies. This is TRES 2b, a gas giant residing some 750 light-years away in the constellation of Draco. It is a world that absorbs nearly all the starlight that dares to touch its surface, retaining a shroud of mystery and intrigue. TRES 2b was discovered in 2006 by the Transatlantic Exoplanet Survey, an international collaboration of astronomers dedicated to finding planets beyond the familiar confines of our solar system. This planet, as large as Jupiter, offers a rather perplexing spectacle. Despite its proximity to its host star, it reflects less than 1% of the light it receives, making it darker than the blackest coal. One might wonder how such a planet came to possess this seemingly unnatural characteristic. The answer lies in its atmospheric composition. TRES 2b's atmosphere is a mixture of hydrogen and helium, common elements for a gas giant, yet it is what else is present, or perhaps not present, that makes it unique. The absence of reflective clouds, which typically play a significant role in bouncing back the light, leaves the planet bare to the universe's gaze. Instead, its atmosphere may contain light-absorbing chemicals, such as vaporized sodium and potassium, which soak up light much like a sponge absorbs water. As we ponder the nature of this distant world, it prompts reflection on the concept of darkness itself. In our earthly experience, darkness is often associated with the absence of light, a void to be filled. Yet in the cosmic theater, darkness can be as much a presence as light, a fundamental aspect of the universe's grand design. TRES 2b embodies this notion, reminding us that the absence of light can reveal as much about the cosmos as its presence. The darkness of TRES 2b is not absolute, however. It is punctuated by a faint, ghostly red glow emanating from the planet itself. This eerie luminescence is not the result of reflected light, but rather the heat generated by the planet's proximity to its star. Orbiting closer to its sun than Mercury does to ours, TRES 2b endures scorching temperatures, soaring to nearly 1,800 degrees Celsius. At such temperatures, the planet's atmosphere emits a dull, incandescent glow, akin to the dying embers of a once-roaring fire. The story of TRES 2b echoes a broader narrative within our universe, where extremes often coexist, and the improbable becomes reality. It invites us to ponder the nature of light and darkness, not as binary opposites, but as intertwined aspects of a cosmic dance. In the silence of space, where time stretches and contracts, darkness holds its own secrets and truths, as profound and as meaningful as those revealed in the light. In contemplating TRES 2b, we are reminded of the myriad forms planets can take, each one a testament to the universe's boundless creativity. It challenges our perception and pushes the boundaries of our understanding, encouraging us to embrace the unknown with curiosity and wonder. As we drift through the cosmos in our minds, floating past the shadows of TRES 2b, we find ourselves in awe of this dark world. It is a sentinel in the night, a reminder of the vast unknown that awaits our discovery. Our journey through the universe is one of endless exploration, where each new revelation brings us closer to understanding not just the cosmos, but our place within it. In the quiet contemplation of TRES 2b, we allow ourselves to be enveloped by the comforting embrace of the universe's mysteries. We find solace in the knowledge that even in the darkest corners of existence, there is beauty and meaning to be found. As we continue our celestial journey, let us carry with us the lessons of TRES 2b, a world where darkness reigns supreme, yet still illuminates the path to greater understanding. As we set our sights beyond the confines of our familiar solar neighborhood, let us embark on a journey to a place both exotic and extraordinary. Known to us as 55 Cancri e, this distant world orbits a star not unlike our own Sun, located a mere 41 light-years away in the constellation of Cancer. Here, we find a planet that stirs the imagination with its dazzling potential, a world that whispers the allure of cosmic riches. 55 Cancri e is a planet enshrouded in mystery and intrigue, primarily due to its unique composition. Unlike Earth, which is largely composed of silicate minerals and metals, 55 Cancri e is believed to be rich in carbon, with a tantalizing possibility. It might harbor vast deposits of diamond. This notion alone propels us into a realm where science fiction flirts with scientific possibility, and where the boundaries of our understanding are both tested and expanded. The planet is classified as a super-Earth, a type of exoplanet with a mass greater than Earth's, but substantially less than that of ice giants like Neptune and Uranus. In the case of 55 Cancri e, its mass is about 8 times that of our home planet, suggesting a robust and dense structure. This density, coupled with its carbon-rich nature, gives rise to the tantalizing hypothesis that diamonds, those enduring symbols of wealth and beauty on Earth, might lie beneath its surface, formed under intense pressure and heat. To envision 55 Cancri e, imagine a world where the landscape glitters with the promise of crystalline treasures, a gem-laden realm born from the cosmic crucible of planetary formation. Here, carbon atoms could be crushed together with such ferocity that they form diamond, creating a planetary core that sparkles with the luster of a jeweler's dream. But let us take a moment to reflect on the processes that might give rise to such a world. Planetary formation is a dance of dust and gas, set to the music of gravity. In the swirling disk of material that surrounds a young star, particles collide and coalesce, forming larger and larger bodies. It is within this primordial ballet that the fate of a planet's composition is decided. For 55 Cancri E, it seems that carbon took center stage, creating a world unlike any in our solar system. The idea of a diamond planet may seem fantastical, yet it is grounded in the principles of planetary science. Carbon-rich planets are theorized to form in environments where the ratio of carbon to oxygen is higher than what we observe in our own solar system. This condition allows carbon compounds to dominate, potentially leading to the formation of diamond under sufficient pressure. While definitive evidence of diamonds on 55 Cancri E remains elusive, the very possibility invites us to ponder the diversity of worlds that populate our universe. Let us also consider the environment of 55 Cancri E, for it is a planet of extremes. Orbiting perilously close to its host star, it completes a full revolution in just 18 hours. This proximity subjects the planet to intense stellar radiation, creating surface temperatures that soar to over 2,000 degrees Celsius. Such searing heat renders the surface inhospitable to life as we know it, but it also contributes to the planet's exotic nature. The intense heat could facilitate the formation of a molten surface, where liquid rock flows like a river of fire. We are left to wonder at the allure of cosmic riches, for while diamonds are precious on Earth, their value is a construct of culture and rarity. On a planet like 55 Cancri E, where diamonds might be as plentiful as pebbles on a beach, their worth transforms into something more abstract, a testament to the boundless creativity of nature. Here, wealth is not measured in carats, but in the awe inspired by the grandeur of the cosmos. In contemplating 55 Cancri E, we are reminded of the vastness and variety of the universe. Each exoplanet we discover expands our understanding of what is possible, challenging our perceptions and igniting our curiosity. The allure of a diamond planet is, in part, a reflection of our innate desire to explore and to understand, to seek out the unknown, and to marvel at the wonders it reveals. As we drift through the stars, let us carry with us the knowledge that worlds like 55 Cancri E exist, each with its own story, its own mysteries waiting to be unraveled. It is a testament to the richness of the cosmos and the endless potential for discovery that lies within our reach. In the quiet of the night, as we gaze up at the stars, may we find comfort in the knowledge that the universe is vast, and that within its infinite expanse, there are wonders beyond our wildest dreams. Gazing up at the night sky, we often find ourselves drawn to the familiar blue of our own planet, a hue that evokes a sense of calm and the gentle lapping of waves against sandy shores. Yet, far beyond our earthly confines, nestled in the constellation of Vulpecula, lies a distant world that shares this azure allure. This is HD 189733b, a planet whose captivating color belies the tumultuous nature of its existence. I'll refer to it as D189 to keep things easy. Discovered in 2005, D189 is a gas giant, not unlike our own Jupiter, but with a personality all its own. Orbiting its star at a distance of about 63 light-years from Earth, this exoplanet offers us a glimpse into a realm where the familiar and the alien blend seamlessly. It belongs to a class of planets known as hot Jupiters, gas giants that orbit extremely close to their parent stars, resulting in surface temperatures soaring to unimaginable levels. The striking blue of D189 is not due to the reflections of tranquil oceans or the scattering of sunlight through a clear sky, as it is on Earth. Rather, this stunning hue is the result of the planet's turbulent atmosphere, rich with silicate particles. These tiny fragments, borne aloft by fierce winds, scatter blue light, creating a visual spectacle that is both beautiful and misleading. For beneath this serene facade lies an environment of extraordinary violence and intensity. Winds on D189 reach speeds of up to 5,400 miles per hour, 7 times the speed of sound. To put this into context, such speeds would allow you to circumnavigate the Earth in a mere 5 hours. These relentless gales whip around the planet, carrying with them not just silicate particles, but also droplets of molten glass, which rain sideways in the hellish atmospheric conditions. It is a place where the familiar concept of weather is turned on its head, where storms rage with a ferocity that defies our terrestrial understanding. The planet's orbit is particularly intriguing, as it completes a circuit around its star in just 2.2 Earth days. This proximity subjects D189 to intense heat, with temperatures soaring to around 1,000 degrees Celsius. The heat from the star, coupled with the planet's rapid rotation, fuels the violent weather systems that dominate its skies. These elements combine to create a world of stunning contrasts, a shimmering blue jewel set against the backdrop of a turbulent cosmic dance. As we reflect on D189, we find ourselves pondering the duality of beauty and chaos that the universe so often presents. It is a reminder that appearances can be deceiving, that beneath the surface of serenity can lie a world of tumult. Yet there is a certain elegance in this cosmic ballet, a harmony within the chaos that speaks to the broader narrative of our universe. This azure world invites us to consider the nature of planetary diversity, challenging our preconceptions about what a planet should be. It serves as a testament to the boundless creativity of the cosmos, where each world is an expression of the unique interplay between its composition, environment, and the forces that shape it. In contemplating D189, we are reminded of the importance of perspective. Our vantage point from a distant 63 light-years away allows us to witness the grandeur of a world that would be inhospitable to life as we know it, yet undeniably captivating. It is a perspective that fosters a sense of humility, as we recognize the vastness of the universe and the myriad possibilities it holds. This distant planet with its azure allure invites us to dream, to imagine the unknown, and to marvel at the wonders that lie beyond our reach. As we drift into slumber, lulled by the thought of D189's swirling storms and sapphire skies, we are reminded of the infinite tapestry of the cosmos and our small place within it. In this state of quiet reflection, we find solace in the knowledge that there is always more to discover, more to understand, and more to inspire our wandering minds. In the vast, unfathomable expanse of the cosmos, where time stretches and dances in the most curious of ways, there exists a world known as PSR B162026b, which I'll call PSR from here onwards. This planet bears the weight of a most venerable age, nearly as ancient as the universe itself. To encounter such a celestial body is to peer into a chapter of cosmic history written in the quiet, enduring language of stardust and time. PSR resides in a stellar conglomerate known as Messier 4, a globular cluster nestled gracefully in the constellation of Scorpius. These clusters are rich tapestries of stars, woven tightly together by their mutual gravitational embrace, forming some of the oldest known structures in our galaxy. It is here, amidst the ageless splendor of Messier 4, that our ancient wanderer drifts, continuing its silent journey through the cosmos. This planet, often affectionately referred to as Methuselah, after the biblical figure renowned for his longevity, has a story that stretches back approximately 12.7 billion years. To put this into perspective, the universe itself is estimated to be about 13.8 billion years old. Thus, Methuselah has witnessed nearly the entire unfolding of cosmic history. It has seen the birth of galaxies, the dance of gas and dust swirling into stars, and the myriad transformations of the universe, each event leaving subtle imprints on its surface, like whispers of epochs gone by. PSR orbits a binary star system, one of which is a pulsar, a rapidly spinning neutron star, the remnant of a supernova explosion, and the other a white dwarf, the final evolutionary state of a star like our Sun. This unlikely partnership of stellar remnants forms a captivating backdrop for the planet's long existence. The pulsar, with its rhythmic and precise pulses of radio waves, acts as a cosmic lighthouse, illuminating the planet's path with an unwavering beacon of timekeeping. The planet itself is a gas giant, somewhat akin to Jupiter in our own solar system, but its exact composition remains a subject of intrigue, cloaked as it is in the mysteries of such an ancient world. Given its age, one might ponder whether its atmosphere holds traces of primordial elements, the building blocks of the early universe. Perhaps, hidden within its gaseous shrouds, are relics of a time when the stars themselves were mere fledglings, emerging from the cosmic nursery. As we contemplate the age of PSR, we find ourselves pondering the nature of time itself. Time, in its essence, is a flowing river, carving its path through the landscape of existence. For Methuselah, time has been both a companion and a sculptor, patiently shaping the planet's destiny over eons. Unlike the fleeting span of human life, the planet's age invites us to consider the slow, deliberate pace of cosmic evolution, where a billion years might pass as the blink of an eye. What stories might Methuselah tell, if only it could speak? Perhaps it would recount the tumultuous birth of its binary star system, the grand celestial dance of its parent stars as they evolved and changed. Or perhaps it would share tales of the countless changes it has seen in the cluster of Messier 4, where stars have lived and died, enriching the interstellar medium with their elemental remnants. In reflecting on this ancient wanderer, we are reminded of the deep connections that bind us to the universe. Methuselah's existence is a testament to the enduring nature of matter, the eternal cycle of creation, destruction, and rebirth that governs the cosmos. It prompts us to consider our own place in this vast expanse, where our lives are but brief flickers in the grand tapestry of time. As we drift into the embrace of sleep, let us carry with us the serenity of Methuselah's gentle orbit, the quiet passage of time that echoes through the universe. In the stillness, we find a connection to the ancient rhythms of the cosmos, a reminder that we are all part of a story that began long before us and will continue long after we are gone. In this way, PSR, the ancient wanderer, becomes not just a distant planet in the night sky, but a bridge to the timeless wonders of the universe. As we drift through the cosmos, our attention is gently drawn to a peculiar world, nestled within the vast reaches of the universe. This planet, Kepler-16b, offers an intriguing spectacle that invites us to ponder the wonders of celestial mechanics and the beauty of cosmic balance. It is a place where reality and science fiction seem to dance together in the celestial ballroom, conjuring images of a double sunset reminiscent of the iconic world of Tatooine from the Star Wars saga. Yet, unlike its cinematic counterpart, Kepler-16b is not the creation of a screenwriter's imagination, but a tangible world within our cosmic neighborhood. Kepler-16b orbits not one, but two stars, a binary system that challenges our everyday perceptions of how planets should behave. The stars, locked in a gravitational embrace, create a dynamic environment where the light of two suns spills across the planet's surface. It's a synchronized ballet that captivates the mind as much as it might baffle the senses. To imagine the sky lit by two celestial bodies, an astronomical rarity that stirs the imagination. Discovered by NASA's Kepler spacecraft in 2011, Kepler 16b defies the conventions of planets bound by a single star. It orbits its stellar companions at a distance of roughly 65 million miles, comparable to the orbit of Venus around our Sun. The stars themselves are a curious pair. One, a K dwarf, smaller and cooler than our Sun, and the other, a diminutive red dwarf. And together they create a celestial duet, their combined light casting an ever-changing tapestry of hues across the planetary sky. The planet circles its binary stars in a near-perfect orbit every 229 days, a testament to the delicate gravitational dance that sustains its path. Its size, comparable to that of Saturn, hints at a gas giant nature, with a composition dominated by hydrogen and helium. Here there are no solid surfaces to tread upon, only swirling clouds and gaseous depths, a realm more akin to Jupiter than our own rocky Earth. Kepler 16b's temperature is another point of fascination. Despite its proximity to its stars, the planet is surprisingly chilly, with average temperatures hovering around -100 degrees Celsius. This frigid climate results from the relatively low energy output of its parent stars, casting a cool, subdued light rather than the intense warmth we associate with our Sun. In this environment, water, if present, would exist not as liquid oceans, but as ice, locked in a perpetual freeze. As we ponder this distant world, the notion of dual sunsets captures our imagination. Picture standing on a hypothetical platform within the planet's gaseous atmosphere, gazing at the horizon where two suns dip beneath the clouds, painting the sky with a symphony of colors. The first sun, larger and more luminous, descends, followed by its smaller counterpart, each leaving a trail of twilight hues that merge and blend into the night. Such a scene challenges our earthly concepts, a reminder of the diversity and creativity inherent in the cosmic order. Binary star systems like that of Kepler 16b are not as rare as one might assume. In fact, they are rather common in our galaxy, with estimates suggesting that up to half of all star systems could be binary or even multiple systems. Yet, the existence of a planet orbiting such a duo remains a delicately balanced marvel. The gravitational forces at play are intricate, requiring a harmonious interplay for the planet to maintain a stable orbit. Too close, and it risks being torn apart by tidal forces. Too far, and it might be flung into the cold void of space. The study of Kepler 16b and its ilk provides us with invaluable insights into planetary formation and stability within binary systems. It broadens our understanding of the myriad ways in which planets can exist and thrive in the universe, expanding our vision beyond the singular star-planet relationships that dominate our solar system's narrative. Here, in the gentle light of two suns, we find a manifestation of nature's boundless ingenuity. Reflecting on Kepler 16b, we are reminded of the vast possibilities that the universe holds, each star system a unique story waiting to be told. The planet's existence, its dual sunrises and sunsets, whisper to us of the wonders that lie beyond our immediate perception, urging us to look up and ponder the skies with a sense of awe and humility. In this silent reverie, we find not only the echoes of science fiction, but the profound realization that the cosmos, in all its complexity, is a place of endless wonder and discovery. In the vast theater of our universe, where stars dance in endless loops and planets weave intricate paths around their luminous partners, there exists a world known as WASP-12b. Discovered in 2008 by the Wide-Angle Search for Planets, this celestial body resides some 1,400 light-years away in the constellation of Auriga. It is a place where time seems both accelerated and fragile, a planet that tells a story of creation and impending demise. WASP-B is a gas giant, somewhat akin to Jupiter in its composition but with a narrative all its own. If we were to measure it, we would find it nearly twice the size of our familiar solar neighbor, yet it holds a mass only 40% greater. This intriguing combination of size and mass makes it what astronomers call a hot Jupiter, a class of exoplanets that orbit very close to their host stars, resulting in extraordinary atmospheric conditions. The story of WASP-12b is one of intimate proximity and perilous embrace. It orbits its star, WASP-12, at a distance so close that it completes a full circle in a mere 1.1 Earth days. This closeness is not without consequence. The gravitational pull of its star exerts relentless force upon the planet, distorting its shape into an ellipsoid more akin to a rugby ball than a perfect sphere. It is a world forever stretched, pulled into a cosmic dance that seems tireless yet is quietly devastating. The surface temperature of WASP-12b is another of its remarkable traits, soaring to over 2,500 degrees Celsius. In such heat, the atmosphere becomes a cauldron, a swirling mix of hydrogen and helium with traces of vaporized metals and other exotic compounds. These conditions create an environment where clouds are scarce, and the sky is a radiant glow, a perpetual twilight that knows no night. However, the most poignant aspect of WASP-12b's tale is its gradual consumption. The star, in its brilliance, exerts a gravitational force so strong that it is gradually stripping the planet of its atmosphere. Hydrogen and other gases bleed into the stellar abyss, forming a luminous accretion disk that spirals inward, a ghostly reminder of WASP-12b's ongoing sacrifice. It is estimated that the planet loses material at the staggering rate of about 189 quadrillion tons each year. For a world of such grandeur, its lifespan is heartbreakingly short. Scientists predict it may be entirely devoured in another 10 million years, a mere blink in the cosmic timeline. As we reflect upon WASP-12b's fate, we are gently reminded of the transient nature of celestial bodies. In the grand expanse of the universe, stars and planets are born, dance their intricate waltzes, and eventually fade, each playing their part in a cycle as old as time itself. WASP-12b's existence is a delicate testament to the balance of forces that govern the cosmos. The gravitational pull that binds it to its star is the same force that will ultimately lead to its undoing. This planetary narrative invites us to ponder the impermanence of all things. Just as WASP-B is reshaped and consumed by forces beyond its control, so too are we subject to the quiet, inexorable passage of time. Yet within this flow there is beauty and wonder. The universe, in its vast complexity, offers us glimpses into processes that span eons, where endings give rise to new beginnings and destruction begets creation. The story of WASP-12b is one of many in the cosmic tapestry, a reminder that even in the face of inevitable change, there is a profound elegance in the balance of forces that shape our universe. As we continue our contemplative journey through the cosmos, we carry with us the gentle assurance that every star and planet, no matter how fleeting, contributes its own unique chapter to the ongoing story of the universe. In the quiet of the night, as we drift into slumber, we might find solace in these celestial narratives, each one a lullaby sung by the stars, whispering tales of wonder and the delicate interplay of forces that govern all that we see and all that remains unseen. As we drift through the vast tapestry of the cosmos, our travels bring us to a curious and paradoxical world known as Gliese 436b. This peculiar exoplanet orbits a red dwarf star, nestled some 30 light-years away in the constellation of Leo. It is a member of a fascinating family of celestial bodies known as hot Neptunes, named for their size and gaseous composition, which resemble our own solar system's icy giant. Gliese 436b presents us with a remarkable contradiction that defies the intuition of terrestrial beings like ourselves. Imagine a place where the very nature of matter seems to play by its own set of rules. Here, ice does not melt, even under the intense heat of a surface temperature exceeding 400 degrees Celsius. Instead, this ice remains resolutely solid, coexisting with conditions that would typically render it to vapor or liquid states. This planetary enigma invites us to explore the complex interplay of physical laws and the unique circumstances that defy our earthbound expectations. The key to understanding this frozen paradox lies in the concept of hot ice, a state of water that is stable at high temperatures due to the immense pressure exerted by the planet's gravitational pull. On Gliese 436b, gravity compresses water into exotic forms, known scientifically as ice VII and ice X, which remain solid against the odds. As we reflect upon this phenomenon, we are reminded of the versatility and adaptability of matter, the fundamental building blocks that compose everything we know. On Earth, we learn early in life the simple dance of water between its liquid, solid, and gaseous forms. We take comfort in the predictability of these transitions, yet here, on this distant world, we find an invitation to reconsider our understanding. The discovery of Gliese 436b was first announced in 2004, marking a significant milestone in the study of exoplanets. It was found using the radial velocity method, a technique that detects the subtle wobbles in a star's motion caused by the gravitational tug of an orbiting planet. This method, akin to observing the gentle sway of a tree branch in the wind, allows us to infer the presence of worlds beyond our own. In considering the paradoxical ice of Gliese 436b, we are also led to ponder the conditions that make life possible. For life as we know it, water in its liquid form is essential. Yet on planets like this, the possibilities for life might be shaped by utterly different principles. Could there be life that thrives under extreme pressures and temperatures, drawing sustenance from chemical reactions unfamiliar to our biochemistry? Or is Gliese 436b a barren landscape, a testament to the diverse yet inhospitable environments that exist within our universe? Such questions remind us of the boundless potential for discovery that lies scattered among the stars. Each exoplanet we uncover expands our understanding of the cosmos and the myriad ways nature can express itself. As we muse on these distant worlds from the comfort of our own, we are encouraged to embrace curiosity and open-mindedness. In contemplating this celestial wonder, we might picture the surface of Gliese 436b, not as a static tableau of unyielding ice, but as a dynamic theatre where the laws of physics perform their intricate ballet. Here, the tension between heat and cold, solidity and fluidity, plays out in a cosmic dance that challenges the rigidity of our assumptions. As we allow our minds to wander among the stars, we find ourselves returning to the notion of paradox. Life itself, after all, is full of contradictions and unexpected turns. Just as we learn to navigate the complexities of our own existence, we must also learn to appreciate the mysteries of the universe without requiring immediate comprehension or resolution. Gliese 436b, with its ice on fire, serves as a gentle reminder that the universe is far more diverse and complex than we might ever fully grasp. And while that thought may seem daunting, it is also deeply reassuring. For in the endless variety of the cosmos, there is an infinite capacity for wonder, an eternal invitation to explore and learn. As we prepare to leave this remarkable world and continue our journey through the universe, we carry with us the lessons of Gliese 436b. It whispers to us of resilience, of the remarkable ways in which nature can adapt and thrive under conditions that seem impossibly adverse. In this whisper, we find both the humility of our limitations and the boundless joy of discovery. Thus we leave Gliese 436b behind, its icy secrets still largely untouched, yet having revealed to us a glimpse of the universe's creative power, a power that, like the best stories, continues to unfold, page by page, across the great expanse of time and space. In the grand tapestry of the cosmos, there exists a peculiar planet that challenges the very fabric of our understanding of planetary systems. This enigmatic world, known as HD 106906b, resides in a corner of our galaxy, about 336 light-years from Earth in the constellation of Crux. I'll call this planet HD 106 going forwards. Unlike the more orderly planets we observe in our solar system, HD 106 stands apart, both in its distance from its host stars and in the mysteries it presents to astronomers and dreamers alike. HD 106 is a gas giant, much like Jupiter, but with several notable differences that make it an object of intense curiosity. Its mass is approximately 11 times that of Jupiter, making it a colossus in its own right. However, the most astonishing aspect of HD 106 is its orbit. It sits more than 730 times the distance from its host stars than Earth is from the Sun. This vast separation, equivalent to about 97 billion kilometers, defies conventional models of planetary formation and dynamics. In the traditional view of planetary systems, planets form from the accretion of dust and gas in a protoplanetary disk surrounding a young star. Over time, gravity coalesces these materials into larger and larger bodies, eventually forming planets that orbit relatively close to their parent stars. Yet HD 106 exists at a distance where such a disk would be too diffuse for planet formation as we understand it. This raises questions about how it came to be where it is, and whether our theories need rethinking. One possibility is that HD 106 formed closer to its host stars and was later ejected to its current orbit due to gravitational interactions. This scenario suggests a chaotic past for the planet, where the gravitational forces of other bodies within the system may have flung HD 106 outward, leaving it stranded in the vastness of space. Such an event would hint at a dynamic and perhaps violent history, where celestial bodies dance to the tune of gravity's unyielding forces. Alternatively, HD 106 might have formed in a manner similar to binary star systems, where a second star forms from the same cloud of gas and dust as the primary star. This would suggest that HD 106 is not merely a planet but a failed star, a brown dwarf that never ignited into stellar life. If this is the case, it adds an intriguing layer to our understanding of what constitutes a planet versus a star. The unconventional orbit of HD 106 also invites us to ponder the gravitational dynamics at play within its system. The planet's distant orbit could potentially be stabilized by a yet-to-be-discovered companion, possibly a smaller planet, or even a group of bodies exerting their own gravitational influence. This hypothetical companion would act as a celestial shepherd, ensuring that HD 106 remains in its wide berth around its stars. The study of HD 106 is not merely an exercise in curiosity. It provides a unique lens through which we can examine the processes that shape planetary systems. It challenges astronomers to refine their models, to consider new possibilities, and to acknowledge that the universe often defies our expectations. The existence of such distant worlds reminds us that while our knowledge is vast, it is not yet complete. As we contemplate HD 106, we find ourselves drawn into broader questions about the nature of the cosmos. What other secrets lie hidden in the dark recesses of space, waiting to challenge our understanding? How many other rogue planets roam the galaxy, solitary wanderers in the night? Each discovery, each anomaly, urges us to keep looking, to keep questioning, and to embrace the mysteries that the universe holds. In the quietude of the night, as our minds drift towards slumber, HD 106 serves as a beacon of curiosity. It is a testament to the allure of the unknown, inviting us to explore and to wonder. The universe, in all its vastness, is a playground of possibilities, where even the most peculiar planets have a story to tell. Perhaps as we close our eyes and drift into dreams, we too become wanderers, voyaging through the cosmic seas, guided by the light of distant stars and the mysteries they hold. In the vast cosmic sea, where stars twinkle like distant echoes of long-forgotten lullabies, there lies a planet that has intrigued astronomers and dreamers alike, Kepler 22b. This celestial body, nestled comfortably within the habitable zone of its parent star, offers a tantalizing glimpse into the possibility of life beyond our humble Earth. As we drift through the fabric of space and imagination, we find ourselves pondering the profound question: what would it mean to discover another Earth? Kepler 22b was first identified by NASA's Kepler Space Telescope in 2009, a time when our own world was abuzz with curiosity about the universe's many secrets. It resides roughly 600 light-years away in the constellation of Cygnus, a distance that both humbles and fascinates us. This planet orbits a star remarkably similar to our Sun, not too hot and not too cold, providing just the right conditions that might support life as we know it. As we envision Kepler 22b, we are drawn into the quiet possibilities that such a planet might hold. It is estimated to be about 2.4 times the size of Earth, a super-Earth, if you will, whispering of landscapes that are familiar yet profoundly different. With a gentle orbit that takes approximately 290 days to complete, its year is not too dissimilar from our own, further fueling the imagination of it being a potential cradle for life. The allure of Kepler 22b lies not just in its size or orbit, but in its placement within the habitable zone. a celestial sweet spot where conditions could allow for liquid water to pool and flow. Water, the elixir of life, is essential for the complex dance of biology, a medium where molecules might meet and mingle, giving rise to the possibility of life forms that could be as simple as single-celled organisms or as complex as the myriad creatures of our own world. In contemplating the conditions necessary for life, we find ourselves reflecting on the delicate balance that makes Earth so uniquely suited to its inhabitants. Our planet's atmosphere, teeming with nitrogen and oxygen, provides the perfect blanket, shielding us from the harshness of space while nurturing the delicate processes that sustain life. Could Kepler-22b possess a similar veil of gases, or does it offer a different cocktail of elements that might harbor life in an entirely novel form? The quest for other Earths, planets where life might flourish, is as much a journey of the mind as it is of technology. It sparks a sense of wonder and curiosity, driving us to peer deeper into the cosmos, to question our place within it, and to dream of what lies beyond the horizon. This pursuit is not merely a scientific endeavor, but a philosophical one, challenging us to consider the vast possibilities that exist in the universe. As we float through this contemplation, we can almost hear the whispers of astronomers past and present, from the early musings of Copernicus to the groundbreaking work of Kepler himself, whose laws of planetary motion laid the groundwork for our understanding of celestial mechanics. Their voices remind us that our search for knowledge is a shared journey, one that transcends time and space. The scientific instruments that probe the distant reaches of our galaxy are extensions of our own curiosity, delicate machines that capture the faint light of distant stars and translate it into data, which we then interpret with awe and humility. The discovery of Kepler-22b is a testament to these tools and to the collective endeavor of human curiosity. In considering the potential for alien life on Kepler-22b, we are reminded of the diversity of life on our own planet, thriving in environments once thought inhospitable. From the sunlit canopies of tropical rainforests to the dark, pressure-laden depths of the ocean floor, life on Earth exhibits an incredible adaptability, suggesting that perhaps life elsewhere could be equally tenacious and varied. The possibility of life on Kepler-22b invites us to imagine ecosystems that stretch the limits of our understanding. Could there be vast oceans teeming with creatures that navigate by senses unknown to us, or lush plains where winds carry the scents of alien flora? The thought is both humbling and exhilarating, a gentle nudge to our imagination, urging it to explore without bounds. As we close our eyes and drift into slumber, Kepler-22b remains a distant enigma, a celestial puzzle waiting to be understood. In its mystery, it captures the essence of human curiosity, that innate desire to explore, to understand, and to connect with the universe at large. Whether or not we ever set foot on its surface, Kepler-22b stands as a beacon of possibility, a gentle reminder of the wonders that await us in the great beyond. In this quiet reflection, we find solace in the knowledge that the universe is vast and full of potential, and that our quest for understanding is as infinite as the stars themselves. As we wander through the corridors of space and time, we are comforted by the thought that we are part of something much greater, a cosmic journey that continues to unfold, one discovery at a time. As we gently continue our cosmic journey through the tapestry of the universe, we find ourselves drawn towards a particularly tumultuous celestial body known as HAT P7b. Situated in the constellation of Cygnus, this exoplanet is a gas giant, a world far removed from the serene stability we often associate with our own blue planet. Unlike Earth, HAT P7b is a place where storms rage unceasingly, sculpting its atmosphere into a perpetual state of chaos and awe. Discovered in 2008 by the HAT-NET project, an astronomical survey aimed at detecting transiting exoplanets, HAT P7b is a fascinating world that challenges our understanding of weather systems beyond the confines of our solar system. With its discovery, astronomers were given a tantalizing glimpse into the wild diversity of climates that exist elsewhere in the universe. This gas giant orbits its host star, HAT P7, at a remarkably close distance, completing a full orbit in just over 2 days. Such proximity subjects the planet to intense stellar radiation, which in turn fuels the violent atmospheric phenomena observed. HAT P7b is classified as a hot Jupiter, a term used to describe gas giants that orbit very close to their parent stars. These types of planets are characterized by high surface temperatures and, in many cases, dynamic weather systems. On HAT P7b, the atmosphere is in a constant state of agitation, driven by temperature differences that create ferocious winds and unrelenting storms. The planet's day side, perpetually facing its star, experiences temperatures soaring to approximately 2,500 degrees Celsius, hot enough to vaporize metals. Meanwhile, the night side is significantly cooler, though still unimaginably harsh by our standards. The interplay between these extreme temperatures results in winds that whip across the planet at speeds exceeding 3,500 kilometers per hour. These are no gentle breezes, but rather fierce gales that would dwarf the most formidable storms on Earth. The sheer power of these winds is a testament to the forces at play in the universe, reminding us of the incredible energy that governs celestial bodies. Observations made using the Kepler Space Telescope have revealed insights into the complex atmospheric dynamics of HAT P7b. The planet exhibits a phenomenon known as atmospheric superrotation, where the upper atmosphere rotates faster than the planet itself. This results in a constant eastward flow of wind, perpetually redistributing heat across the planet's surface. The movement of clouds and thermal patterns creates dramatic shifts in brightness, observable even from afar. Interestingly, the clouds on HAT P7b are not composed of water vapor like those on Earth. Instead, they are likely made of corundum, the mineral that forms sapphires and rubies. Imagine a sky filled with clouds of shimmering gemstones, reflecting the intense light of the nearby star. This exotic weather system is a vivid illustration of how diverse planetary atmospheres can be, shaped by unique chemical compositions and environmental conditions. The study of such distant worlds with their extraordinary weather patterns offers a humbling perspective on our own planet's climate system. While Earth is not immune to storms and tempests, they are but fleeting disturbances within a largely stable environment. In contrast, HAT P7b's storms are a permanent feature, an intrinsic part of its existence. This serves as a reminder of the delicate balance that allows life to flourish here, amidst the vast, chaotic backdrop of the cosmos. As we reflect on HAT P7b, we might ponder the forces that drive such relentless atmospheric activity. The planet's proximity to its star provides the energy necessary to sustain these tempests, much like the sun powers weather patterns on Earth. Yet, the scale and intensity of HAT P7b's storms are magnitudes beyond our experience, a testament to the diversity of planetary climates that exist in the universe. It is in these moments of contemplation that we appreciate the boundless creativity of nature. Each planet, whether serene or stormy, tells a story written in the language of physics and chemistry. Hat P7b, with its perpetual storms and sapphire clouds, speaks of a world shaped by forces both familiar and alien to us. It invites us to explore, to seek understanding amidst the tumult, and to marvel at the complexity of the universe we inhabit. Thus, as we drift softly into the embrace of sleep, let our thoughts wander across the cosmic sea, where planets like Hat P7b swirl in a dance of perpetual storms. In the quietude of night, we find solace in the knowledge that even in the vastness of space, there is beauty to be found in the most tumultuous of places. And perhaps in our dreams, we might catch a glimpse of those distant sapphire clouds, carried on winds that whisper the secrets of the stars. In the vast tapestry of the universe, where stars twinkle like distant memories and galaxies spin in an eternal dance, there are worlds that defy our earthly expectations. One such world lies far beyond the comforting warmth of our sun, a planet known as Ogle 2005 BLG 390 LB. I'll refer to it simply as Ogle from here on out, as the name is a bit of a mouthful. It's a name that might seem cold and impersonal, yet it fits a world where cold is more than just a sensation. It is a defining feature. Discovered through the method of gravitational microlensing, Ogle sits in the realm of exoplanets that challenge our understanding of what's possible in the cosmos. This method, which involves observing the bending of light from a distant star by an intervening object, allows astronomers to detect planets that would otherwise remain hidden. In 2005, during a collaborative effort that spanned the globe, this icy planet was revealed to us, orbiting a star about 20,000 light-years away in the constellation of Scorpius. As we imagine our journey to this frozen world, we must first consider the conditions that define it. Ogle is often referred to as a super-Earth, a classification that speaks more to its mass than its temperament. With a mass approximately 5 times that of our own planet, it sits on the boundary where rocky planets may begin to blend into icy giants. Yet, unlike Earth, the warmth of its star is but a distant echo. It orbits a red dwarf star, a type of star known for its longevity, but also for its relative coolness and dimness. If one could stand on the surface of this world, a thought experiment more than a practical possibility, one would find themselves in a place of unimaginable cold. Temperatures on Ogle plummet to around 220 degrees Celsius, a degree of chill that renders the landscape not just inhospitable, but utterly alien. Water, as we know it, would be locked in a permanent state of ice, hard as stone. The atmosphere, if it exists in any familiar form, would be a thin veil, perhaps composed of exotic ices and gases compressed into solidity by the relentless cold. This frozen world invites us to ponder the extremes of temperature in the universe. While our planet enjoys a temperate climate courtesy of its perfect distance from the sun, Ogle resides in perpetual winter. Such extremes challenge our understanding of habitability. On Earth, life finds a way in the most unexpected places: deep ocean trenches, arid deserts, the frozen Antarctic. Yet on Ogle, the concept of life would require a redefinition, a new set of rules that accommodate the near absence of heat. It's a testament to the resilience of planetary bodies, how they form and endure in conditions far removed from those that cradle life as we know it. This resilience speaks to the broader narrative of the cosmos, where diversity is not just a trait of life, but of the very worlds themselves. Each planet, each star, tells a story written in elements and energy, a narrative that unfolds over billions of years. In the silence of Ogle, we find a certain elegance. Its frigid nature is not a failure of warmth, but a different kind of beauty, one that invites reflection on the nature of extremes. Here, the boundary between solid and gas blurs, and the very atmosphere may glitter like a frozen aurora under the distant, feeble light of its star. The discovery of such a planet also highlights the ingenuity of human curiosity. With telescopes and equations, scientists have reached across the void, piecing together the characteristics of a world that, until relatively recently, existed only in the realm of imagination. The search for exoplanets like Ogle is a journey of discovery that challenges us to expand our horizons, to envisage what other forms planets might take and what other conditions might exist. As we bring our thoughts back from this icy frontier, there is a gentle reminder of the vastness and variety that the universe holds. Each visit to these distant worlds expands our understanding of what is possible. Ogle, with its icy embrace, stands as a testament to the incredible diversity of planetary systems. It prompts us to ponder not just the extremes of temperature, but the resilience and beauty that can be found even in the coldest corners of existence. In this cosmic chill, there is a quiet lesson about adaptation and endurance, qualities not just of life, but of planets themselves. As we leave this frozen world behind in our imagination, we carry with us the sense of awe and wonder that comes from exploring the unknown, a reminder of the boundless curiosity that drives us to seek out the mysteries of the universe. In the vast theater of stars that make up our galaxy, there lies a small, unassuming star system just over 4 light-years away from us. Its name is Proxima Centauri, a name that carries with it a sense of proximity and familiarity, like a neighbor just beyond the garden fence. Within this star system, there is a planet that has captured the imaginations of astronomers and dreamers alike, Proxima Centauri b. Proxima Centauri itself is a red dwarf star, the most common type of star in our galaxy, though often overlooked due to its diminutive stature. It is a faint, steady glow in the sky barely visible without the aid of telescopes. Yet, despite its modesty, red dwarfs like Proxima Centauri have an enduring quality, burning their nuclear fuel slowly and steadily for billions of years. This longevity offers ample time for any orbiting planets to develop the conditions necessary for life. Proxima Centauri b orbits its star at a distance that places it within what is known as the habitable zone, a region where liquid water could theoretically exist on a planet's surface. This tantalizing possibility has led to much speculation about whether Proxima Centauri b could harbor life, or indeed, support human life in the future. However, the reality of this exoplanet is both complex and enigmatic, a reminder of how little we truly understand about the cosmos. The planet itself is slightly more massive than Earth, with a diameter that suggests it could be a rocky world, much like our own. Its orbit around Proxima Centauri is remarkably swift, taking a mere 11.2 Earth days to complete a full revolution. This proximity to its star, while placing it within the habitable zone, also subjects it to intense stellar activity. Proxima Centauri is known for its flares, bursts of radiation that could strip away any atmosphere and bombard the surface with harmful radiation. This presents a paradox of sorts. The very conditions that make Proxima Centauri be an intriguing candidate for habitability could also render it inhospitable. Yet, as we ponder these challenges, we are reminded of the resilience of life on Earth, which has thrived in some of the most extreme environments imaginable. Could life in some form find a way to endure on Proxima Centauri b? The prospect of interstellar exploration, of one day visiting our nearest stellar neighbor, is a notion that stirs the imagination. In the grand scheme of the universe, 4 light-years is but a stone's throw away. Yet, even this modest distance poses significant challenges with our current technology. The fastest spacecraft ever built, the Parker Solar Probe, would take over 6,000 years to reach Proxima Centauri. Clearly, new breakthroughs in propulsion and space travel would be required to bridge this cosmic divide. Despite these hurdles, the dream of reaching Proxima Centauri b endures. It represents a stepping stone, a tangible goal within the vast ocean of stars. The potential rewards are immense, not just in terms of scientific discovery, but also in the profound perspective it would offer. The idea of standing on another world, looking back towards our own sun, is a humbling thought. It prompts us to reflect on our place in the universe and the bonds that tie us to other worlds, however distant they may be. As we contemplate these possibilities, we find ourselves drawn to the notion of connection. Across the light years, Proxima Centauri b stands as a silent witness to the same cosmic events that shape our own world. We share with it a common origin, forged from the same stellar nurseries that gave birth to stars and planets alike. In this sense, Proxima Centauri b is not just a distant planet, but a reminder of the interconnectedness of all things in the universe. The exploration of Proxima Centauri b, whether through telescopes, robotic probes, or one-day human visitors, is a journey of discovery that mirrors our own journey of understanding. It is a testament to our innate curiosity, our desire to explore beyond the familiar and uncover the mysteries of the cosmos. In seeking to understand Proxima Centauri b, we also seek to understand ourselves, our origins, and our future. As we drift gently towards sleep, let us imagine the scene, a quiet, rocky landscape under the faint glow of a red sun. The horizon stretches outwards, vast and unexplored, inviting us to step forward, to journey onward, to dream of what lies beyond. In the quiet of the night, Proxima Centauri b whispers to us across the void, a neighbor reaching out a hand in the darkness. It is a whisper we long to answer, a connection we yearn to make. In its presence, we find a reflection of our own world, a place of wonder, possibility, and hope. In the vast expanse of the cosmos, where stars flicker like distant memories and planets dance in cosmic orbits, we find a peculiar world known as Camet-9b. This is no ordinary planet, and its existence challenges our understanding of what a planet can endure. Nestled in the constellation of Cygnus, approximately 670 light-years away from Earth, Camet-9b defies conventional wisdom with its extraordinary temperatures. Indeed, it is often described as the hottest planet ever discovered, with surface temperatures that soar to heights that would make most stars blush. Camet-9b was discovered in 2016 by astronomers using the Kilodegree Extremely Little Telescope, hence its name. Its discovery was a marvel of modern astronomy, showcasing the sensitivity and precision of instruments designed to peer deep into the heavens. With temperatures reaching an astonishing 4,300 degrees Celsius, Camet-9b is hotter than many red dwarf stars. To put this into perspective, this is just a few thousand degrees shy of our sun's surface temperature. This blistering heat is primarily due to Camet-9b's proximity to its host star, Camet-9, an A-type star significantly hotter and larger than our own sun. The planet orbits so closely that it completes a full revolution in less than 2 days. Such proximity results in a phenomenon known as tidal locking, where one hemisphere of the planet perpetually faces the star, enduring relentless, searing heat, while the other side remains in a state of perpetual darkness. One might wonder, how does a planet withstand such extreme temperatures? The answer lies in the resilience of matter under intense conditions. On Earth, we are familiar with materials that melt or vaporize under heat. However, on Celt 9b, the atmosphere is a cauldron of exotic gases, with hydrogen molecules likely being torn apart into atomic hydrogen before recombining on the cooler, dark side of the planet. The intense irradiation from its star also means that Celt 9b is constantly losing its atmospheric gases. It's as if the planet is slowly evaporating into the cosmos, leaving behind a trail of hydrogen, much like a comet's tail. This dramatic process is both a testament to the planet's resilience and a sobering reminder of the transient nature of celestial bodies under extreme conditions. The atmosphere of Celt 9b, if we could stand on its surface, would likely be an inhospitable mix of vaporized metals and other elements, sculpted by the fierce winds that rage between the day and night sides. The sheer scale of these atmospheric forces is hard to fathom. Winds could reach speeds of thousands of kilometers per hour as they attempt to redistribute the immense heat. Reflecting on Celt 9b, we are invited to consider the vast spectrum of environments that the universe is capable of producing. In many ways, this planet acts as a natural laboratory, offering insights into the behavior of matter at high temperatures and pressures. It challenges our preconceptions of habitability and the conditions under which planets can exist. The discovery of such an extreme world also prompts a deeper reflection on the nature of resilience. If a planet can endure such extremes, what lessons might it offer us about the endurance of life and matter under adversity? While life as we know it could not survive on Celt 9b, its very existence suggests that the universe is replete with wonders that stretch our imagination and inspire a sense of curiosity and awe. As we continue to explore the cosmos, each new discovery adds a brushstroke to the ever-expanding canvas of our understanding. Celt 9b serves as a reminder that the universe is not only vast, but also filled with extremes that challenge our understanding of planetary science. In this cosmic theater, planets like Celt 9b are the actors in a play of epic proportions, each with a story to tell, each with a lesson to impart. And so, as we drift into slumber, let us ponder the incredible resilience of Celt 9b and the boundless possibilities that lie beyond the stars. The universe, in all its grandeur and mystery, continues to invite us on a journey of discovery, one that transcends the boundaries of our earthly experience and expands the horizons of our cosmic imagination. Far beyond the comforting glow of our own solar system lies a celestial marvel that defies the typical expectations we might have of planetary behavior. Let us turn our attention to HR 5183b, an exoplanet situated approximately 102 light-years away in the constellation of Virgo. This distant world is distinguished not by its size alone, but by the peculiar path it takes through the cosmos, a path that challenges our understanding of planetary orbits and the gravitational forces that guide them. Imagine, if you will, a planet many times the mass of Jupiter, our solar system's own gas giant. HR 5183b is indeed a giant, but what truly sets it apart is its eccentric orbit. Unlike the nearly circular orbits of the planets we know so well, HR 5183b traces an elongated, egg-shaped trajectory around its host star. This unusual orbit is more like that of a comet, swooping close to the star at one end and swinging out into the vastness of space at the other. It is as if the planet is engaged in a cosmic dance, with each step determined by gravitational forces that we are only beginning to comprehend. The discovery of HR 5183b was made possible through the diligent observations of astronomers who study the subtle wobbles of stars. These wobbles, or stellar radial velocity shifts, occur due to the gravitational tug of orbiting planets. In the case of HR 5183b, the star's dance is slow and deliberate, revealing the presence of a planet with a long and languid orbit. It takes approximately 45 to 100 Earth years for HR 5183b to complete one full revolution around its star, a testament to the vastness of its celestial journey. The eccentricity of HR 5183b's orbit raises intriguing questions about the dynamics of planetary systems. How does a planet come to possess such an unusual orbit? Theories abound, with many scientists suggesting that gravitational interactions with other massive bodies could be responsible. Perhaps HR 5183b once had a planetary sibling, another giant with which it engaged in a gravitational duel, flinging each other into eccentric orbits until one was ejected from the system entirely. Such cosmic interactions remind us of the delicate balance that governs the dance of the planets. In reflecting upon HR 5183b, we are invited to ponder the forces that sculpt the universe. Gravity, that ever-present yet invisible force, shapes the orbits of planets, the paths of comets, and the structures of galaxies. It binds together the cosmic web, creating a tapestry of celestial bodies that move in harmony or in chaos. The eccentric orbit of HR 5183b is a testament to the complexity and beauty of this gravitational interplay. As we contemplate this distant world, we are reminded of the broad spectrum of possibilities that exist beyond our own corner of the universe. HR 5183b challenges our assumptions and expands our understanding of what planetary systems can be. It serves as a gentle reminder that the universe is filled with wonders that defy easy categorization. In the quiet of the night, as we gaze up at the stars, we can take comfort in the knowledge that there are still mysteries to explore and questions to ask. The journey of HR 5183b is but one chapter in the grand narrative of the cosmos. It invites us to dream of worlds yet to be discovered and to imagine the myriad forms that celestial bodies might take. In the serene stillness of the universe, we find not only questions but also a profound sense of wonder. The eccentric giant, HR 5183b, continues its solitary orbit, a silent witness to the unfolding story of the stars. In the quiet embrace of the night, as the world around us gently falls into slumber, we find ourselves at the threshold of the cosmos, that vast, unending expanse that stretches beyond the limits of our imagination. Here, in the serenity of this moment, we stand as humble observers, gazing up at a sky that has inspired wonder and curiosity since time immemorial. The universe, with its intricate tapestry of celestial bodies, dances in a rhythm so grand and ancient that it defies the confines of human understanding. Yet, it is in this very mystery that we find solace, an endless source of inspiration and contemplation. The planets, those steadfast companions of the stars, weave their way through the cosmos in a dance that is both predictable and profound. Each one is a world unto itself, a testament to the diversity and creativity of the universe. As we have ventured through the realms of the weird and the wondrous, we've glimpsed the astonishing variety that exists beyond our own pale blue dot. These planets, with their peculiarities and marvels, remind us that the universe is far more intricate than our earthbound perceptions might suggest. Consider for a moment the sheer scale of it all. Our solar system, a tiny speck in the grand scheme of things, is but one of countless others scattered across the vastness of space. Each star, each solar system holds its own secrets, its own potential for life and wonder. The Milky Way, our galactic home, is a sprawling city of stars, each one a beacon of possibility. And beyond it, billions of other galaxies stretch out into infinity, a cosmic web of unimaginable proportions. In this grand ballet, the planets play their parts with precision. They orbit their stars, held in place by the gentle yet unyielding force of gravity. This force, a fundamental aspect of the universe, guides their paths and shapes their destinies. It is the same force that binds us to our Earth, that gives weight to the apples falling from trees, and keeps our feet firmly planted on the ground. Yet, it is also the force that allows us to dream of reaching for the stars. Our journey through these celestial wonders is not merely an exploration of physical phenomena, but a voyage into the depths of our own curiosity. We are drawn to the unknown, to the questions that linger just out of reach. What lies beyond the horizon? What secrets do these distant worlds hold? It is this innate curiosity that has driven us to explore, to invent, and to understand our place in the grand scheme of things. As we ponder these questions, we find ourselves in the company of great thinkers and dreamers who have come before us. From the ancient astronomers who charted the stars to the modern scientists who send probes to the farthest reaches of our solar system, we are part of a lineage of explorers. Figures like Galileo, Copernicus, and Vera Rubin have illuminated the path, each contributing to our ever-growing understanding of the universe. Yet, despite our advancements, the universe retains its mystery. There are phenomena that defy explanation, worlds that challenge our preconceived notions, planets with molten surfaces, others shrouded in perpetual darkness, and some with atmospheres so alien that they seem to belong to a different reality altogether. Each discovery adds another layer to our understanding, yet also reveals the vastness of what we do not know. It is this blend of knowledge and mystery that makes the universe so profoundly beautiful. The more we learn, the more we realize how much there is yet to discover. In this interplay of light and shadow, certainty and doubt, we find a deep sense of humility. We are but stardust, forged in the hearts of dying stars, given form and consciousness in a universe that has existed for billions of years. As we drift into the gentle embrace of sleep, let us carry with us a sense of awe and wonder. The planets and stars above us are more than mere points of light. They are reminders of the infinite possibilities that surround us. In their dance, we see the echoes of creation, the timeless story of the cosmos unfolding with each moment. So let us dream of the stars, of the worlds yet to be discovered, and the mysteries awaiting our curious minds. Let the cosmic dance inspire us to seek knowledge, to embrace the unknown, and to find comfort in the vastness of space. For in this endless dance, we are all participants, joined in a shared journey through the cosmos. As the night deepens and the stars twinkle softly above, we come to rest in the knowledge that the universe is alive with possibility. And as we close our eyes, we remain part of this magnificent, endless cosmic dance.